Hey everyone, and welcome back. We're about to take a deep dive into a topic a lot of you have been asking about: aluminum engine blocks.
Yeah, this is a really cool one.
So, you know how we do things here. We go deep, we dig into the details, we look at it from all sides.
That's right. We're going to look at why aluminum is such a popular material for engine blocks, how those complex things are even made.
And what it all means for you behind the wheel. We've got some great sources lined up: research papers, industry articles, all sorts of stuff.
We're going to unpack those sources, pull out the most interesting bits.
Okay, let's dive right in. I was looking at this article here, and it claims that aluminum is the accurate metal for engine blocks. Accurate. That's a strong word.
I see what they're getting at, though. It really is all about aluminum's properties. They line up perfectly with what a modern engine needs to perform well.
Okay, so break that down for me a bit.
Well, first of all, think about weight. One of the biggest advantages of aluminum is that it's much lighter than, say, cast iron, which is what engine blocks used to be made of.
Yeah, that makes sense. Lighter engine, lighter car.
Exactly. We're talking a potential weight reduction of 50 to 100 pounds just by switching to an aluminum engine block.
Wow, that's a lot. And what does that mean for me as a driver?
Well, for one thing, better fuel economy. A lighter car simply requires less fuel to move. We could be talking about a noticeable increase in MPG, maybe even up to 5 more miles per gallon.
Okay, I'm liking the sound of this already. Anything else?
Yeah, don't forget about performance. A lighter car is also going to be more agile, more responsive. You'll feel it in the handling, in the acceleration. It just makes for a more enjoyable driving experience overall.
Nice. This source also talks about aluminum having excellent conductivity. I know engines generate a lot of heat, but why is conductivity such a big deal?
It all comes down to heat management. Your engine's a complex system with a lot of moving parts, a lot of friction, a lot of combustion going on in there. It gets extremely hot, obviously.
Right, like a pressure cooker.
Exactly. And that heat needs to be dissipated quickly and efficiently. Otherwise, you're going to have problems like overheating, engine damage, costly repairs, the whole 9 yards.
Okay, so that's where aluminum comes in.
Precisely. Aluminum is a fantastic conductor of heat. It's like a super efficient radiator, pulling heat away from those critical engine components and preventing things from getting too hot. This keeps everything running smoothly and helps extend the life of your engine.
This is fascinating. Now, one thing that surprised me in this research is the mention of repairability. I always thought once an aluminum engine block cracked, it was toast.
I hear you. It used to be that way, but technology has come a long way. There are specialized welding techniques and materials now that allow mechanics to actually repair cracks and damage in aluminum blocks.
Really? So it's not necessarily death sentence for the engine anymore.
Nope. And that makes them even more cost-effective in the long run. Now, I'm curious about how they actually make these complex engine blocks. The source talks about sand casting molds, which sounds so old school.
It does. I picture like blacksmiths and stuff.
It is an ancient technique, actually, but with a modern twist. Basically, they create a mold out of sand and then pour molten aluminum into it.
Molten aluminum. Sounds dangerous.
Oh, it is. It's incredibly hot, almost like lava. And those molds have to be incredibly tough to withstand that intense heat and pressure.
So wait, they make a brand new mold for every single engine block? Doesn't seem very efficient.
That's where the modern twist comes in. They've developed ways to make these sand molds reusable, which is key for keeping manufacturing costs down.
Okay, that makes more sense.
Yeah.
But I imagine those molds take quite a beating with all that heat.
Oh, absolutely. The biggest challenge is preventing the mold from warping or deforming during the casting process.
Oh yeah, I could see how that would be a problem.
You got it. It's like baking a cake. You don't want it to sink in the middle. So engineers use really sophisticated computer simulations and special materials to reinforce the mold and ensure every engine block comes out perfectly shaped.
Wow, it's amazing how much science and engineering goes into making these things. Speaking of engineering, the source points out that aluminum engine blocks can actually reduce wear and tear on other parts of the vehicle. That seems counterintuitive.
Think about it this way. Remember how we talked about aluminum being lighter? Well, that weight reduction doesn't just benefit the engine. It takes stress off of the entire drivetrain.
The drivetrain.
Yeah, your transmission, your brakes, your suspension, even your tires, they're all working a little less hard because they have less weight to move around.
Just like taking off a heavy backpack, everything just feels lighter.
Exactly. That translates to less wear and tear, fewer repairs, and longer life for those components. So an aluminum engine block isn't just good for your engine, it's good for your whole vehicle.
Now, one thing that caught my eye was the mention of a company called Sunrise Metal. They're highlighted as a leader in aluminum engine block technology. Now, we're not endorsing them or anything, but it just goes to show how specialized this industry has become.
Oh, absolutely. There are companies out there entirely dedicated to developing and manufacturing these high-tech engine blocks. It's a fascinating intersection of materials science and automotive engineering. So, to sum all this up, aluminum is strong, lightweight, and conducts heat like a champ, making it a pretty awesome material for engine blocks.
Right. But making those blocks is a complex process that involves high temperatures, reusable sand molds, and some serious engineering know-how to make sure everything comes out just right.
And that brings up a really interesting question. If aluminum is so great for engine blocks, why aren't all engines made from it? What are the trade-offs? What are the limitations?
That's something for you all to think about. Why don't we see aluminum in every engine out there? There's a whole world of material science and engineering that goes into answering that question. Keep exploring, and maybe we'll cover it in a future deep dive. Thanks for joining us, everyone.
See you next time.